Hello guys, a colorful welcome to all of you from your physics friend. So today we'll going to acquire some knowledge about the initials to chapter of class 11. Okay, so today we aren't going to learn anything new. So the first two chapter is physical world and units and measurements. Okay, so they are quite informative, so I decided to define this video. I already note down some points and I will discuss about it using some examples. Okay, so briefly, so first comes mathematical tools. Okay, mathematical tools means here in class 11 and 12 physics you will face some numericals in physics. Okay, so to find out their answers or to solve them we'll get the help of mathematics. So yeah, in class 11 12 mathematics you will see sine theta, cos theta, integration, differentiation, binomials, so that will be known to you. So this part and they're easy, but this part will be required to solve the problems of gravitation. Okay, only one problem, derivations actually. So this is something different. Why it is different? In binomial we know that part. Okay, so binomial expansion 1 plus x whole to the power n equal to something like that, and it comes from actual formula 1 plus nc1 x plus dot 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 nc2, something like that. But here you can see that the exponent is negative, but this formula only valid for positive n, but I write it's valid for both n negative and positive. It's valid only for this reducing form. Okay, so when this nc1 can be reduced to n, this nc2 can be reduced to n into n minus 2, n minus 1 by 2 factorial. So this negative sign can be used here so that we can easily find out such negative exponent uh, expression expansion. Okay, so now we can limit it here. The next is physical world. So physical world, here comes some definitions or the origins of the word physics, science. So what is physics? There are many scientists, they have many thoughts about physics. Okay, so combining them it's physics. Okay, so we can say it's the branch of science dealing with the nature and natural phenomena. Okay, so natural phenomena, yes, everything in nature can be analyzed by physics. Okay, so that is physics. Now science comes from Latin word scientia, means to know, and physics also comes from a Greek word physis, means the nature. Okay, so okay, that's also information. Now I just said and this physics or the physics follows some laws or basics laws. Okay, so among them two important one is relativity, theory of relativity, and laws of quantum mechanics. Okay, so there are so many laws as well. Okay, basics laws we will discuss about it later and you will study in more details in your entire course. But these two laws or these two part of physics will not be very widely covered in your syllabus, that's why I mentioned it here. So relativity is the theory of invariance in nature and the theory covering the motion of the higher speed moving particle. The higher speed moving particle means the particle's velocity compared to light. Okay, we know the fastest particle, the fastest thing is light, which move faster than anyone in the nature. And although for the sense of humor we can say that shadow can be as comparable to as light or faster than light. Okay, your shadow, we can say your shadow always comes before your motion, the light motion, right? So just jokes apart. Next, quantum mechanics. It is theory of mechanical behavior of submicroscopic particles. So what is submicroscopic particle? You will get to know it chemistry more. It is just a submicroscopic particle. You can say it is. There are some particles which are too small to be seen in ordinary light's microscope. Okay, so that's there. Now comes to force that part will you have to realize more widely. So force you can say you have good idea about it because you have learned it numerically rather than physically in your class 9 10th, right? So there you read about acceleration, velocity, then force. Mass into acceleration is force, but actual force is you can say by which we can do some work generally. And the most of the forces in the nature is due to exchange of particle between two bodies. That's mean if you consider you are applying some force on a body, so you are providing a force to the body, right? So something is there which converting which transmitting the force from you to that body, right? So that particle or those particle is known as field particle. And this type of force are called exchange force. Okay, so there are few types of exchange force described here. First, gravitational force, it is weakest force, and the field particle is graviton. You can see that the field particle is graviton here. And then okay, the important property about gravitational force is it is central and conservative force. Central force means the gravitational force acts between the point joining them. Suppose if there is two bodies and the gravitational force is acting, then the gravitational force must act on the line joining them. And the conservative force means the force which will path independent while you will done some work by this force. Okay, or you can say for a cyclic process the work done by the force is zero. Okay, and the range of this force is 0 to infinite. In the chapter gravitation we will see it later. And we will take any other force's strength relative to gravitational force. So we will take gravitational force as a reference frame or reference force. So the relative strength of gravitational force is 1. Now comes to okay, and one more thing is it is the weakest force in nature, already mentioned. And next, weak force. Weak force, they are in between nucleus, the interaction between lepton, mesons, baryons, they are elementary particle. And in some weak interaction, neutrino acts as the field particle. So neutrino, you will probably heard it in nuclear physics, or at class 12 you will heard about it. I will limit it to here. And the range is very very small, it is quite femtometer actually, but the strength with respect to gravitational force or the weakest force, it is 10 to the power 25 times. Okay, so now comes to electromagnetic force. Electromagnetic force, it is from the name it you can see that electro and magnetic. So there is some part called electric and there is some part called magnetic. So these two field simultaneously makes electromagnetic force. Okay, later on you will get in details. And here the photon is the field particle, and it is its range is quite up to infinite. Okay, as well, and it is central and conservative in nature also. And actually okay, and it is 10 to the power 36 times stronger than the gravitational force. Next, one last force we can say nuclear force. We can say it is the strongest force in the nature, existing in the nature, and it is quite short range force, 10 to the power minus 15 meter. That's been quite few femtometer as well. And the elementary particle for this force is pi mesons. And they are so the example you can say it is the interaction between nucleons and mesons. Okay, so when the nuclear reaction takes apart or radioactive particles or neutrino comes from nucleus. Okay, so that's and the strength is 10 to the power 38 with respect to gravitational force. And it is partly central and partially non-central force. Okay, and because it has some different types of potential energy arrangement. Okay, so the potential energy arrangement, actually you will come to know later that the stability of system or stability of particle depends upon this potential energy distribution. So if this distribution is uh, quite different or quite abnormal, so then it is due to central and non-central force, we can say that, for that reason. Okay. Okay. Next, we can say leptons. Leptons, it's an important particle, elementary particles, and it includes electrons, muons, neutrino, antineutrino of them. Okay. Okay, they are elementary class, elementary particles. And next we come to conservation of laws. In physics, most of the laws, most of the theoretical laws actually follows the conservation. They are conservative in nature. Suppose we have already learned about conservation of mass, conservation of energy. Next we will came to know that conservation of linear momentum, and more conservation of charge later on the 12th first chapter, electrostatics, conservation of nucleons number in nuclear physics, and many more. Okay. Now comes to units and measurements. This chapter is also familiar to you. I will not go in details also. You know some fundamental units which are not derived unit, and they can spontaneously express themselves, like meter, kg, second, ampere. There are 7 fundamental unit as well. We all know as per the SI system. Kg, second, ampere, candela, Kelvin, and there are some definition, a standard definition already allocated by the system of units and measurements, or SI system. And okay, no, I will not discuss. And yes, there are some special types of units as well. Light year, astronomical unit, parsecs. Okay, so you will get to know about it later as well, or you can follow any standard books to know about them. Okay, so, and there are some fundamental units, and there are another types of units called derived unit. So the derived units are those which are combination of fundamental units. So we can derive such unit by using the fundamental units. That they are derived units, just like velocity. The unit of velocity is meter per second, acceleration, right?